All right, so chapter 1, the automobile. The objectives after studying this chapter will be able to identify, describe primary automobile assemblies and major automotive systems, explain the frequency, electronic interactions of major automotive system circuits, describe and compare major automobile designs. Identify and locate the most important systems used to operate conventional hybrid passenger vehicles. Comprehend later textbook chapters with a minimal amount of difficulty and be able to answer the questions in the back of the book. So the automobile, derived from the Greek words autos, which means self, and French words mobile, which means moving. And the technology applies is the application of math, science, physics, engineering, and other subjects. The parts, assemblies, and systems. Parts or components are smallest removable items on the car. Assemblies are a set of fitted parts designed to complete specific functions, and systems are a group of related parts and assemblies that perform specific functions. So parts, let me fix here. A little bit better. There, that's a little bit better. So parts are individual components, like fuel pumps, things like that, air filters. Assemblies are a group of parts put together for a specific function. And so, such as a fuel pump assembly could be your fuel pump, a fuel filter, and a fuel sending unit that tells you how much fuel is in the tank in one unit. They're all creating the same specific function that's going to be an assembly. And a system is a group of related parts. So speaking of fuel, fuel pump, fuel lines, fuel injectors, and stuff like that, which are not assembled together, but they're all part of the same system. All right. Major vehicle systems, the frame, body, and chassis. That's one of your major systems. Your engine, computer systems, fuel systems, electrical systems, cooling and lubrication systems. Having some issues with it. And your exhaust emission control systems. For some reason it's messing up on my screen. Fix something. I'm having technical difficulties. I'm reading off of two separate screens, so I know what I'm saying to you guys that are using the Spanish version. I guess that's just not going to work, is it? All right, exhaust emission control. So some examples there in that picture of major vehicle systems. This wants to give me so much trouble. Better. All right, so we have, your fuel tank here. Your air goes into the throttle body, your intake manifold, which goes into your engine. Just an example of how all these major systems kind of work together for your vehicle to run and stuff. All right, your frame is your metal structure, provides mounting place for all other parts, such as your suspension, the body, the engine. Your body is just the skin that forms the outside of the vehicle. Your chassis is the vehicle's frame and everything mounted to it. So your chassis is going to be the frame with the suspension and all of that stuff mounted to it, is what it's saying. You have two different types of chassis. You have body over frame construction, known as full frames. This is mainly used on vans, pickup trucks, and SUVs nowadays. Older cars used to use that. They don't anymore. To save weight, they use what is a unit body construction. It's also called a unit body or a unitized construction. It uses, it's used on passenger cars. It's the most common design. Saves a lot of weight, makes the car easier, faster to manufacture. Also makes it cheaper because of that. So that's why you see it a lot of times on the car. So body over frame is going to have a big metal frame structure and the whole body is going to mount to it. Whereas the unibody looks like this. So it has the components that a frame would have, such as your bumper supports, your rocker panels, things like that. It's all mated into this body of the vehicle, essentially. So it's unionized together instead of being two separate components. You can see here. So the chassis looks like that. You have two frames, one in the rear, one in the front. These are called subframes, or sometimes called cross members. You can see the engine and suspension and other systems will mount to this. General vehicle specifications. Vehicle curb weight is total weight with a full fuel tank and no driver. Vehicle weight distribution is downward force on the front and rear tires. So a car that's 50-50 distributed, that means half the weight's on the front tires, half are on the back. Something like a pickup truck might be more closer to 65 or maybe even 70 in the front and 30% of the weight in the back, because a lot more stuff's in the front than is in the back. You have a bed in the back that's pretty open. Vehicle wheelbase is the distance between center line of the front and the rear wheels. So that's the length of the wheels. Track width is the distance between center lines of two wheels on the same axis. So vehicle wheelbase is the length, whereas track width is the width of it. So if you're looking at the front from the center line of both tires, how wide that is track width. Vehicle length is the distance between the outermost point of the front bumper and the outermost point of the rear bumper. So vehicle length is how much from front to rear the total car is, whereas wheelbase is how far the wheels are from each other as far as length. Vehicle width is the widest point from right to left side of the body, perpendicular to the vehicle center line. So how wide it is on the body. The body sticks out a little bit farther than the wheels. Vehicle height is the distance from the ground to the highest point of the roof line. Vehicle sizes, you have full size, mid-size, compact, and like the picture here, this is an example of a mini compact. Compact cars are small cars. Mini compacts are very small. Mid-size, you know, is your average four-door car you see out there. A full size is going to be like the very large luxury cars, things like that. Aerodynamics is the study of the motion of the air as it interacts with a moving object. The coefficient of drag, or CD, is the number that represents the force required to move the passenger vehicle through the air. So coefficient of drag isn't just an automotive term. Coefficient of drag could be in aeronautics or motorcycles, anything. It's just how much force is required to move that item through the air. All right, there's an example of some body types. You have a sedan right here. You can see it has a little trunk, 4 doors, stuff like that. Convertible, no top. Hatchback, you can see the roof line goes all the way to the very back together. Sport utility vehicle, these are kind of like a truck, just with the back half on it. Minivan, and then your station wagon. Station wagon looks similar to the hatchback, but it's much longer. It's usually 4-door, things like that. Fuel efficiency is the rating of how far a vehicle can travel on 1 gallon of fuel. So gasoline, diesel oil, or a stored electrical energy, that's going to tell you your fuel efficiency is going to tell you one of those. So however many miles per gallon of fuel or diesel, gasoline or diesel, or how long per charge of electricity. Also referred to as fuel economy. Testing and the rates are done through the EPA. The EPA actually sets standards that certain years the vehicles can't be below a certain amount. Basic engine parts, you have a block, cylinder, piston rings, pistons, connecting rods, crankshaft, cylinder heads, combustion chamber. All of these are parts of the engine block or the engine. And we will dive into that later on when we learn actual components of the engine. And we'll actually go into shop. I'll let y'all take one apart so you can see the insides of it as well. So that will come later on in this semester. There's a picture kind of showing you everything, how it goes together. Your valve train, your pistons, your block, your cylinder heads, all of that stuff. Automotive internal combustion engine normally uses 4 strokes. 4 piston strokes equal 1 cycle. Multi-cylinder engines, 2, 3, 4, all the way up to even 12 cylinders. So a cylinder is what kind of rates how big the engine is, and then you also have the size of those cylinders as well. Like I said, we get into this a little bit later on in the semester, so a lot of this will make more sense later on. All right, computer systems, they are composed of sensors, electrical control modules, and actuators. So you have various amounts of computer systems in vehicles. There are so many in there. There's hundreds of them in some of these new vehicles. They all control different things. They all talk to each other. They communicate with each other. That way the vehicle works better. That way the vehicle is much more convenient for people. You're not having to manually do stuff as much anymore. Makes the vehicle more efficient as well, and things like that. Fuel system. This introduces the correct amount of fuel into the system for an efficient combustion. You have something known as the air-fuel ratio, which is the percentage of air to fuel. Gasoline injection system uses engine control module, sensors, and fuel injectors to electrically meter the fuel. So we can electrically control how much fuel is going to the engine. And it's very important. That way we get a proper air-fuel ratio. If we have too much fuel and not a lot of air, the system is known as rich. It doesn't burn as efficiently. We don't get as much power out of it. The same as if it's the other way. If we have too much air and not enough fuel, the system is known as lean. This can cause too much heat and can damage engine components as well. So we got to make sure we're running the right air-fuel ratio, which is typically around 14.1 pounds of air to 1 pound of fuel. It can vary a little bit. We can be a little bit more lean to conserve fuel. or we can add a little bit more fuel and add to make a little bit more power, depending on what we're trying to do with the vehicle. But it's going to be around that 14.7 to 1 ratio, like I was saying, 14.7 pounds of air to 1 pound of fuel. Electrical systems, you have your ignition systems, which are high voltage surge. A high voltage surge ignites air fuel mixture. So when we get the air and fuel in there, we need some way to make a spark, to make a bang, push the piston down, create power. Your starting system, which has an electrical motor that rotates the engine until the engine can run on its own power. This though requires a battery. So we gotta have that 12-volt battery to create this, to make this happen, along with the starter motor and some other electrical devices as well. You have a starting system. So once the engine is running, we have a charging system that running engine can create electricity instead of having to draw it constantly from the battery. You have a lighting system for interior, exterior lights and components. Oh, excuse me. Says fuses, wires, switches, relays, things like that. You have a lighting system to help you see at night as well when you're driving. You have a cooling system. This maintains constant engine operating temperature. So we have in an internal combustion engine, we have burning fuel. These little explosions, controlled explosions, create a lot of heat, upwards of thousands of degrees. So we need to keep it cool. Otherwise, it will start melting things and cause a bunch of damage. So we have a cooling system that will maintain that and keep it cool. We also have a lubrication system. This reduces friction and wear in between internal engine parts. There's a lot of metal moving around. We need a lubrication system so those metals aren't grinding up against each other and wearing each other out. We have an exhaust system, which quiets the noise produced by the engine operations. This also routes the exhaust gas to the rear of the vehicle. Exhaust gas is poisonous. It has carbon monoxide in it, so we want it to leave the vehicle safely behind the vehicle. We do not want it entering the vehicle's passenger compartment. Emission control system, which reduces the amount of toxic substance produced by an engine and fuel system. So as fuel burns, it produces chemicals and toxins that get in the air. It's bad for the environment, bad for everybody else. So we have emission controls. So this controls those toxic substances from entering the atmosphere. So we have different types of filters, different types of systems to do different things to prevent that stuff from being either created or transforming it into another substance that isn't as toxic or bad for things. Your drivetrain system transfers the turning force from the crankshaft to the drive wheels. Most common drivetrain configuration is front wheel drive. Obviously, the front wheels are pulling the vehicle. Rear wheel drive, which means the rear wheels are pushing the vehicle, and all wheel drive, which means all four wheels are working together to propel the vehicle. So some different designs here. Front engine, as you can see, the engine's in the front of the vehicle, and rear wheel drive. So the rear wheels are pushing the vehicle. Here we have a mid-engine. So if you look at the engine, it's in between the front and rear tires. That's what classifies it as a mid-engine, a middle of the vehicle engine. If the engine was behind the rear tires, this would be a rear engine. So that's the only difference. I know it's not in the exact center of the vehicle, but that's not what classifies it as a mid-engine. It's in between the two tires, two axles. If the engine falls somewhere in the front up here or in the back like this one, that's a mid-engine. You can see it also is rear-wheel drive to push the vehicle forward as well. You have front-wheel drive, front engine, front-wheel drive. So the front wheels pull the vehicle forward, as well as the engines in the front It's in front of the front axle as well. And then you have all drive. So the engine, it could actually be placed in a number of places. It could be mid-engine, rear engine, front engine, whatever. But the engine on this one's in the front, but you have axles going to all four wheels so that all four wheels can propel the vehicle equally or how they need to. Drivetrain parts consist of clutches, a clutch, transmission, so your manual, semi-automatic or automatic transmission, drive shaft, rear axles or any type of axles, things like that. So this is a picture of an automatic transmission. Cutaway, so you can see the inside, your torque converter, valve bodies, your housing, clutches. Don't worry about what a lot of that stuff is. We'll get into it later on in the semester in another lesson. This is your rear axle assembly. So as you can see, we have to transfer power in one direction and split it in two and send them out in either directions. So we have a set of gears in the back there that does that. There's something called a ring gear. And then you have a pinion gear, which drives the ring gear. So they work together to create that transfer of power, as well as it changes the gear ratio to create a little bit more power as well. Suspension system, this allows the wheels and tires to move up and down with little effect on the body movement. We want to be comfortable when we drive. We want the vehicle to handle well. The suspension system does this. Steering system, obviously, we need to steer the vehicle. We can't go everywhere in a straight line. So we need some way to steer the vehicle. That's what steering system is going to be. And we also need to be able to stop. You don't want a 3,000-pound vehicle that's not able to stop. That's not going to be a good day. So there's an example of the front springs and suspension system, along with the steering and the brake system as well, some components there. And this is a picture of a rear suspension system. This is known as a dead axle. It kind of simulates what a differential would do, but say it's a front wheel drive vehicle. We don't need an axle in the rear, so we just have this this lighter weight component here that kind of acts like it in its place. It's just called a dead axle. So the suspension mounts to that to provide its means of absorbing bumps and things like that. Accessory systems. Accessories are items that you don't need in a vehicle. These are more luxury items and stuff like that. A vehicle doesn't necessarily need them to run, but it is nice for them to have it. So things like your air conditioning, your sound system, we want music when we're on long trips, power seats, power windows, rear defogger, safety systems such as seat belts, airbags, things like that. You don't need those things for the vehicle to work and function as a vehicle, but it is nice to have that stuff. Hybrid vehicles, hybrid electric vehicles, HEV, combines two methods of propulsion, internal combustion engine, and an electric drivetrain. So it has a regular engine and runs on gasoline, but also has an electric motor as well to assist that gasoline engine so it doesn't burn as much fuel. Hybrid drivetrain part consists of a motor generator, your high voltage power cables, high voltage battery, high voltage power control module. All hybrids use regenerative braking. When we get into brake systems later on in the semester, we'll talk about regenerative braking, but essentially the electric motors help stop the vehicle, not your conventional brakes. That way it saves the brake systems. Whoops. Too many times. That's Okay. So if there's any questions you have, please see me after class or something. Let me know. And I will get it figured out for you and everything as well. So be sure to get your work done and stuff like that in class. These slides, hopefully these videos are helping you as well. So